Boxplots. These are graphical summary of the distribution of data. It's developed from the quartiles for a data set. Figure 2.22 shows the box plot for the home sales data. Steps to use to construct the box plot for the home sales data. A box is drawn with the ends of the box located at the first and third quartiles. For the home sales data, first quartile or Q1 is equals to 139,000 and Q3 is 256,625. This box contains the middle 50% of the data. A vertical line is drawn in the box at the location of the median, 203,750 for the home sales data. By using the interquartile range IQR that is equals to Q3 minus Q1, limits are located. The limits for the box plot are 1.5 IQR below Q1 and 1.5 IQR above Q3. For the home sales data, IQR is equals to Q3 minus Q1 equals 256,625 minus 139,000, that is equals to 117,625. Thus, the limits are 139,000 minus 1.5 times 117,625, which is equals to negative 37,437.5, and 256,625 plus 1.5 times 117,625 equals 433,062.5. Data outside these limits are considered outliers. The dashed lines in this figure are called whiskers. The whiskers are drawn from the ends of the box to the smallest and largest values inside the limits computed in step 3. Thus, the whiskers end at home sales values of 108,000 and 298,000. Finally, the location of each outlier is shown with an asterisk. In this figure, we see one outlier, that is 456,250. Steps used to construct the box plot follow. A box is drawn with the ends of the box located at the first and the third quartiles. This box contains middle 50% of the data. A vertical line is drawn in the box at the location of the median. By using the interquartile range IQR equals Q3 minus Q1, limits are located at 1.5 RQR below Q1 and 1.5 RQR above Q3. Data outside these limits are considered as outliers. Measures of association between two variables, including scatter charts, covariance, correlation coefficient. The measures of association between two variables uses scatter charts, which is a useful graph for analyzing the relationship between two variables. Covariance, descriptive measure of the linear association between two variables. The sample covariance for a sample of size n with the observations x sub 1, x sub y sub 1, x sub 2, y sub 2, and so on, is s sub xy equals the summation of x of I minus the mean times y sub I minus the mean of y all over n minus 1. The population covariance uses this formula. Table 2.14 shows the data for bottled water sales at Queensland Amusement Park for a sample of 14 summer days. The scatter chart in the figure suggests that higher daily high temperatures are associated with higher bottled water sales. This is an example of a positive relationship because when one variable, in this case high temperature, increases, the other variable, or the sales of bottled water, generally also increases. The scatter chart also suggests that the straight line could be used as an approximation for the relationship between high temperature and sales of bottled water. Because the covariance is greater than zero, it indicates a positive relationship between the high temperature and sales of bottled water. This verifies the relationship in the scatter chart. That is, as a high temperature for a day increases, sales of bottled water generally increase. If the covariance is near zero, then the x and y variables are not linearly related. If the covariance is less than zero, then the x and y variables are negatively related, which means that as x increases, y generally decreases. Computation of covariance and correlation coefficient in Excel. In this figure shows the data from the previous table entered into an Excel worksheet. The covariance is calculated in cell B17 using the formula equals covariance dot S open parenthesis A2 colon A15 comma B2 colon B15. The A2 colon A15 defines the range for the X variable, high temperature, and B2 colon B15 defines the range for the Y variable, sales of bottled water. The correlation coefficient in this figure is computed in cell B18 for the sales of bottled water using the formula equals correl or CORREL open parenthesis A2 colon A15 comma B2 colon B15, where A2 colon A15 defines the range for the X variable and B2 colon B15 defines the range for the Y variable. Correlation coefficient measures the relationship between two variables, not affected by the units of measurement for x and y. Sample correlation coefficient is denoted as shown in this slide. The closer the correlation coefficient is to +1, the closer the x and y values are to forming a straight line that trends upward to the right, or a positive slope. The closer the correlation coefficient is to -1, the closer the x and y values are to forming a straight line with negative slope. This figure shows the scatter diagrams and associated covariance values for different variable relationships. In A, we have a positive correlation. X and Y are positively linearly related. In B, approximately zero. X and Y are not linearly related. In C, negative. X and Y are negatively linearly related. Example, to determine the sample correlation coefficient for bottled water sales at Queensland Amusement Park, we have this formula. S sub xy is 12.8 all over S sub x, which is 4.36, times S sub y, which is 3.15, that is total of 0.93. There is a very strong linear relationship between high temperature and sales because the value is greater than zero. This figure shows example of nonlinear relationship producing a correlation coefficient near zero. Thank you for watching. Please share or like and subscribe to our YouTube channel.